All right, 4.1, derivative and the tangent line problem, part 1. So we divided this section into two to make our lives a little easier. And we're going to start with something called the slope of the secant line. So if I have any graph, like this one right here, I can pick any 2 points and find the slope of this line that goes through those 2 points of whatever graph it may be. And if you remember slope, if I want to find the slope of this secant line, which is why I have m here, remember slope-intercept form, y equals m plus b, m is slope. So the slope of the secant line is equal to what? The change in x, right? Just like in your slope formula that you learned before. Change in x is on the bottom. And then up top here, remember f of whatever is your outputs, your y value. So it's f of c plus the change in x minus f of c. So what's happening whenever we change between these two in terms of y is on the numerator, and the denominator is change in x. So it's another way of writing it. Now, as we get closer and closer to a singular point, whichever value you want to call your, when it goes through just one part of your graph, wherever that may be. So let's say this, where I have a laser at right now. Let's say we're trying to find a slope at that given part of your graph, okay? Not 2, 1. That would be called a tangent line, okay? And we're going to talk about calculating tangent lines in the next page. Now, go ahead and pause and write down the stuff up top here. Here's why this makes sense, okay? There is only one point you're trying to find, right, that you're finding the slope of, okay? Which is why x is approaching 0. It's like you're finding 2 points, but there's no change involved, right? So its limit as x approaches 0 of this basically the same function that belongs right here, right? So it's like you're doing 2 points, but with no change at all, which is why it's written like this for your tangent line. So if we do an example together, find the slope of the graph of this, right? So let's go through this. So we set it up. The c value is whatever is the x value in your order pair you're trying to find the slope of at that given point. And then we're going to plug in this whole expression in here, and then this, we're just going to evaluate f of -1. So we're going to have 3 minus, we'll put a 5 there first, 5 parentheses 1 minus -1 plus change in x, minus, we plug in -1, you're going to get an 8. So minus 8 over change in x. So we simplify, distribute the -5, you're going to get 3 plus 5 minus 5, change in x, minus 8, change in x approaches 0, and then 8 minus 8 is gone, so I'm left with limit as the change of x approaches 0 of -5 over -5 times change in x over change of x. Change in x cancels, so I'm left with it's equal to -5. So the slope of this equation at the given point would be -5. Some of you might have been able to tell that before doing all this because, hey, slope's -5, the whole line. But for some of the other problems, when we don't have a linear line, this is going to come in handy. Okay, for this one, we have multiple points we want to find the slope of. So what I'm going to do is I'm going to leave, instead of plugging it, like the last one we had -1 as the c value, I'm going to leave it as c so I can just plug it at the end and have a good time. Once again, limit of the change of x approaches 0. F of c plus change in x minus f of c over change of x equals limit is the change of x approaches 0, and we plug it in, so it'd be 6 minus parentheses c plus change x squared minus f of c would just be 6 minus x squared. Make sure you put this whole thing in parentheses, or else you're in trouble. Then when we go to the next part, I'm going to FOIL c plus change in x. So when I FOIL, it'll be c squared plus 2c change in x plus change in x squared. And then over here we just do negative, so negative 6 plus x squared over change of x, and then distribute negative. Minus c squared minus 2c change of x minus change of x squared minus 6 minus x squared over change of x. I just realized I should have made this should have been c. My apologies. Should have been c. So then when we go through this, that should be plus anyway. So c squareds cancel. So I'm going to cancel in red so they can see. So c cancel gets you 0. And then 6 minus 6 is 0, goes away. So I'm left with, what am I left with? Negative 2c change of x minus change of x squared over change of x. And then we can finally get to the point when we cancel out the change of x's and we get negative 2c minus the change of x. It's the limit as the change of x approaches 0, so this goes to 0, and then I'm left with just what? Negative 2c. Now how does that help us? Now I'm given 2 points in the beginning, right? These were your 2 points right up here. So since we just found the equation, I can simply plug in 1 and 2 and get the slope. So at 1, 1 times negative 2 is negative 2, and at 2, negative 2 times 2 is negative 4. So those are your 2 slopes, negative 2 and negative 4. And what we have been just doing is basically derivative. If you pause the video, you can write down what the definition of derivatives, which is right here. It's pretty much the same limit that we've been doing, which is fun. So let's find what the derivative of this function is, okay? So the derivative of this function, let's do what we did before, limit change of x approaches 0, and we put in that x plus change, or where we see an x, so it would be 2 minus x plus change of x squared minus 2 minus x squared. Get over to change of x, we go to FOIL, 2 minus, distribute negative sign, negative x squared minus 2x change of x minus change of x squared minus 2 plus x squared all over change of x. I just distributed negative to both these terms after I FOILed, wait till after you FOIL, and then negative to both these, which is why it's negative 2 and x squared. What happens? Do we see things cancel? Yes, we sure do. X squareds cancel, 2 minus 2, and then we get what's left over. Now we can cancel out everywhere we see change of x, at least one of them. Leave me with 1. I have 1 left over because I have negative 2x minus change of x, and the limit as the change of x. I'll put a change there. If x approaches 0, so this goes to 0, and I'm left with just negative 2x as your answer. And so negative 2x is the derivative of this function right here. Okay, cool. Appreciate you watching, and we'll see you later.